When it comes to stealth games, most developers overthink hiding systems. But what if there's a simple approach that feels more intuitive to players? Here's an NPC patrolling the side of a building with tall grass on both ends of the patrol route. Seemingly convenient locations for a stealth takedown. The player spots the pattern, waits for the right moment, then hides in the tall grass at one side of the building as soon as the coast is clear. Everything looks perfect. The grass provides visual cover, the timing seems right, and the unaware NPC is walking straight into a trap. As the NPC returns to this location, something goes wrong. Despite being visually hidden in the tall grass, the player is spotted immediately. The takedown is thwarted. The NPC goes into alert mode, and the player is killed. The NPC lives to tell the story, and our stealth approach has completely failed. This is the frustration players experience in poorly designed stealth games. Hiding spots that should work simply don't. It breaks immersion and makes the game feel unfair. On the second attempt, our player tries a different approach. Instead of the first grass patch, they choose to hide in the tall grass on the other side of the building. Visually, it looks identical, same grass, same height, and same cover. But this time, it's positioned not directly in the patrol path, but next to it. Perfect for a takedown from behind. The unaware NPC approaches and doesn't notice the player hiding in the tall grass at all. As the NPC scans the perimeter, completely oblivious to the danger, the player sneaks up from behind and executes a perfect takedown. Same visual hiding spot, same tall grass, and same NPC, but completely different result. One location gets you killed, while the other guarantees success. What made the difference? The answer reveals a fundamental problem with how most developers approach stealth mechanics. They rely heavily on complex line-of-sight systems, ray tracing, and visibility calculations that often produce inconsistent results. Players end up frustrated because what looks like it should work doesn't. The solution is a hidden volume system paired with Unreal's AI perception, and it's elegantly simple. Instead of relying purely on line of sight, there's an hidden volume in the second grass patch. When the player enters this volume, they get flagged as hidden, and the NPC's perception system ignores them completely. While hidden, there is a caveat. If the NPC gets too close, the player will lose the hidden flag and is spotted. This proximity-based detection ensures the stealth system feels realistic and prevents exploitation. Players can't just sit in one hiding spot forever. It creates natural tension. You're safe from detection, but if an NPC's patrol route or search pattern brings them too close, your cover is blown. Hit the like button if you find this valuable, and share your thoughts on stealth systems in the comments. When the player enters the hidden volume, we set their hidden flag to true. The AI perception system checks this flag before processing the player as a valid stimulus for sight, so hidden players become effectively invisible. But should the NPC enter the hidden volume also, we clear the hidden flag and the player becomes detectable again. You can place hidden volumes exactly where you want stealth gameplay to occur. Players can use these designated hiding spots to avoid detection. but still need to time their movements and approaches carefully. This also opens up interesting level design possibilities. You can create multiple hiding spots with different strategic advantages, force players to move between cover points, and design patrol routes that create natural opportunities for takedowns. The NPC doesn't need complex AI to create engaging stealth gameplay, as the environment itself becomes part of the challenge. There is a link in the description for the project files. Now watch this video next to learn how to set up the perfect takedown animation, and I'll see you there.